This is the second video for writing the equation of a line in slope-intercept form. There are 5 cases of writing the equation of a line in slope-intercept form based off of the given information in the problem. And instead of looking at them as 5 cases, we almost want to look at them as their one case. And for all 5 of the cases, we ultimately need the point and a slope to write the equation. So that's how we're going to treat them, as though they're one case. Is just focus on getting a point and getting a slope. Now, they may not give you both a point and a slope, so you have to use what you know to come up with that missing piece. So a lot of times the slope is the missing piece. So we might have to derive the slope or just use the information they give us to help us determine what that slope is. So in order to write the equation of a line, we use one of 2 equations. We use slope-intercept form, which is y equals m times x plus b, or we use point-slope form, which is y minus y sub 1 equals m times the quantity x minus x sub 1. And in both formulas, m represents a slope, b represents the y-intercept, and then x1 and y1 represent the coordinates of your specific point that's given in the problem. Now in this video we're going to focus on 2 specific cases, and these cases are going to deal with when you have parallel lines or perpendicular lines. So it's important for us to understand what those mean. So 2 lines are parallel if they never intersect each other, so they never cross one another. So if you think about this, this means the lines have the exact same slant or tilt. So it follows that if you have a line 1 and you have a line 2, that ultimately their slopes are the same. So we use m again to represent slope. So if I want to compare m1 to m2, and I go ahead and say line 1 is parallel to line 2, then it doesn't matter what I give you for slope of line 1, line 2 should be the same. So I'm saying line 1 has slope 3, so it follows if the lines are parallel, slope of line 2 is 3 as well. So that's pretty straightforward, so keep that in mind. If we're dealing with perpendicular lines, again, you're going to have 2 lines, but this time they're going to actually intersect one another, and when they intersect, they form 490-degree angles. So it may not be as obvious as how the slopes relate to one another, but basically the slopes are opposite in sign and reciprocals of one another. So for example, say my line 1 has slope 2, and my line 2 is perpendicular to line 1, so its slope would be opposite in sign, so it would be negative, and it would be the reciprocal of 2. So 2 is the same as 2 over 1, so the reciprocal of that is 1/2. So my slope would be negative 1/2. Let's go ahead and consider one more example where we have perpendicular lines. If I say my slope for my line is negative 2/3 of my line 1, then my slope for line 2 that's perpendicular is going to be positive, and then it's going to be the reciprocal, so a positive 3/2. So that should be straightforward, and it's important that you keep those concepts straight because that's how you're going to be able to solve the next 2 problems. So notice in this problem, this is our case 4, we're given a point on your line and we're given the equation of a line that is parallel to our line. So notice that the equation that's given is not the equation of my line. So it's important to, when you're taking note of the information that's given you, that you focus on 2 lines, because you don't want to mix the information up and think this is for line 1 when it's really for a different line. So line 2 we'll call it. So in my example it says write the equation of a line that passes through the point negative 2, 4 and is parallel to the line with the equation 2y equals 6x minus 8. So notice, if you want to write the equation of a line, you ultimately, as always, need a point and a slope. Well, they do give us a point. They give us negative 2 comma 4, but the slope is not given to us. Instead, they tell me that I am parallel to a line that has the equation 2y equals 6x minus 8. So my line 2 that I am parallel to, and we often use these symbols to represent parallel, is 2y equals 6x minus 8. Now we do know that parallel tells us about the slopes of these 2 lines. We do know that that means these guys' slopes are the same. Now if I'm in this particular form for my equation for line 2, you can't see the slope. the only way you really can see the slope right off the bat is if it's in slope-intercept form. So it's important that y is solved for. So I'm going to go ahead and solve for y by dividing by 2 on every single term. So if I do that, I get y equals 3x minus 4. So now I'm in slope-intercept form, so I should be able to see the slope. And obviously here the slope is 3. Well, since my line 1 is parallel to line 2, I can go ahead and say line 1 slope is also 3. So that was just side work so that I could have my slope and my point. So now I can go ahead and use one of my two equations, and in this case I'm going to use point-slope form because they don't give me the y-intercept, equals, so y minus my y sub 1 is equal to m times x minus x sub 1. So go ahead and plug in for the y sub 1, plug in for your m, and plug in for your x sub 1. And notice I'm putting parentheses here to help me keep track of my signs so I don't make any mistakes. So 4 is going to go in my y sub 1 position, 3 is in for my m, and negative 2 is my x sub 1 because it's my x coordinate. So this cleans up as y minus 4 equals 3 times the quantity x plus 2, because a minus and negative is a positive. So y minus 4 is 3x plus 6 if I distribute. And then I want y solved for, so I'm going to go ahead and add 4 to both sides. So y equals 3x plus 10. So my equation of my line 1, which is what I want, is y equals 3x plus 10. So notice, if I were to graph these two lines, and we can go ahead and do this so you can kind of see that these lines really are parallel. Now if I look at the, first off, if I look at the equations, I'd be able to see that they're parallel because the slopes are the same, they're both 3, and the y-intercepts are different. And the importance of the y-intercepts being different is because if they were the same, you'd have the exact same line. So I'm going to go ahead and graph my first line, which has the y-intercept at 10. So I'm going to plot the point 0, 10. And then my slope is 3. So it's 3 over 1. So my rise is 3 and my run is 1. But I'm going to go ahead and fall 3 instead because I'm kind of running out of room here. And if I fall 3, I'm going to go to left 1. That keeps things positive. And I can do that again and again, but basically I'm going to get the following line. So this is my line 1. My line 2 has a y-intercept of negative 4, so 0, negative 4 is the point I need to plot. And then my rise is 3, and my run is 1. So I'm using the slope. And if I connect the dots as best as I can see that these lines really are parallel. So I see it from the equation, but I also see it if I were to graph it. So this would be a good check if you ever want to check. So now let's go ahead and consider our fifth case where we're given different information, and in this time we're going to be given a point on our line, but the equation of a line that we are perpendicular to. So notice it's perpendicular, not parallel. So they tell us to write the equation of a line that passes through the point 0, negative 6 and is perpendicular to a line with the equation 4y minus 2x is 10. So the objective again is writing the equation of a line. So the equation that I'm going to want to write the equation for is line 1. So I'm going to go ahead and I'm going to figure out what's a point that I can use and what's a slope, because that's what I need in order to write the equation. Well, they do give me a point. They give me the point 0, negative 6. However, if I read that information, a slope is not directly given. However, I should be able to see that I can come up with my slope using the second line that they give me, its equation. They give me the equation 4y minus 2x is 10. So I should be able to see the slope for line 2 if I get it in slope-intercept form, which ultimately means solve for y. So if I solve for y, that means I have to add 2x to both sides, and then I need to divide by 4 on every term. So when I do that, I get 2/4 x plus 10/4 on the right hand side. So y equals, I have to simplify these fractions, so 1/2 x plus 5/2. So notice all the work I've done so far with this equation is for an equation that I am perpendicular to. So keep that in mind. You don't want to mix up your information as you're going along. So I do know that the slope that I'm perpendicular to is 1/2. So if I want the slope of my line, I just need to go opposite in sign, so negative, and do the reciprocal of 1/2, which is 2/1, or 2 is another way to say that. So now I have a point and I have a slope, and I can use one of my two equations now to write the equation of a line. So this side work here for line 2 set me up to just substitute values in. Since the point here is 0, -6, we should notice this is a special point. In fact, this is a y-intercept because the x-coordinate is 0. That's how we can recognize that it really is a y-intercept. So we know that our b is -6. So I have my m and my b, so it makes sense to use slope-intercept form to write the equation of my line. So I'm going to go ahead and do that, and I'm going to substitute in for m, and I'm going to substitute in for b. So my m is -2, and my b is -6. So if I rewrite this, I get y equals -2x minus 6. So this is my equation of my line. And if you go back and you read the information that they gave you, you should see that 0, -6 satisfies this equation, y equals -2x minus 6. But also you should see that the slopes are opposite reciprocals. So if I want to check this graphically, I can. And so I'm going to go ahead and graph line 1, and its intercept is at 0, -6. So I need to drop 6 units, or fall 6 units. So at 0, -6. And my slope is -2, so I need to fall 2 and go to the right 1. Now I can go ahead and connect my points to the best of my ability. So you get the idea. And this is my line 1. So this should be perpendicular to my line 2. So I'm going to go ahead and plot line 2. I'm going to plot its slope, I'm going to plot its y-intercept, which is at 0, 2, and 1/2. And then for every one that I run or rise, I should rise 1, I should run 2 units. Connect the dots or points, and you can see from my rough sketch that these do intersect at a 90-degree angle. So these lines are perpendicular. So in the two videos that I've presented, we have covered 5 cases where we're given different pieces of information, but we've attacked the problems the exact same way. So it's as if we were dealing with one problem. We attacked them to where we just found a point and we figured out the slope if needed, and then we wrote the equation using either slope-intercept form or point-slope form. So if you ever have to write the equation of a line, this is the approach you're going to need to take.